probably should have come in here and set up for the talk before, but I'm going to leave Larry. So this one is a little bit of mental exercise. It's just sort of exploring ideas about specific technology. Specifically, it sort of starts with the idea of what does it mean to be a dynamic language? When we started working on Perl Steps with Eric years and years ago, there wasn't really a whole lot of receptiveness to the idea that you would need a highly performant virtual machine for a dynamic language. It's kind of like, oh, those scripted languages like Perl, you don't really need to pay attention to those. Those aren't serious languages. In the time since then, there's been a lot of change in that perspective of the world in general. And you find now that serious virtual machines like JVM and .NET are really, really actively pursuing languages like Perl. And there's a lot of reasons for that. Probably the biggest reason is that they're responding to the needs of their users. They have found that there's enormous demand among programmers for what dynamic languages provide them. So when programmers want to work in those tools, there's a good reason for the people who write the tools to start supporting them. So one of the ideas that I've had over time, what you see is sort of on the horizon of computer science, is you see something like C'ism coming up. The best illustration that I can find for that is in linguistics. About 50 years ago, there was this split between two different theories. One was Chomskyan, the Chomskyan theory of linguistics, and then there was another model called the functional model of linguistics. And really, there are two different ways of looking at the same set of problems. They're two perspectives on the same thing. They're a particle or a wave perspective of looking at light. Light can be examined as either a particle or a wave. And both perspectives provide very good value to the problem that you're trying to solve. So a lot of people look at the static and dynamic distinction, something like this. Right? So a static language is one in which things are done at compile time. A static feature is one that's performed at compile time, more or less. A dynamic language is one in which things happen at runtime instead of at compile time. So it's not really a hard divider like that. It's more of a sliding scale. So no language can actually do everything at compile time. That wouldn't actually be a tool to get work done. At some point or another, you want to make a change in the universe, and you don't want that to all happen at compile time. You can't. And on the other hand, you can't really quite do absolutely everything at runtime. There's always a starting point at which you have to read your code and make it so that the machine can run it. So most languages actually sit somewhere right here around the middle. Languages like C, they drift a little bit more to one side. Languages like Perl drift more to the other side. So I'm going to run through just a few ideas from Dynamism. They're probably going to be familiar to you. So one way that people sometimes characterize dynamic languages is dynamically typed languages. Like in Perl, you don't have to think about whether your variable is a number or a string or an object. Your variable can hold any kind of value. This is really a red herring. This isn't what really defines dynamic languages. It's also the least interesting feature of dynamic languages. Another one is dispatch. So whether you, let's see, one good illustration would be in Perl, selecting at runtime which routine you want to run. Autoload is a good example of that. Maybe you don't actually know ahead of time what function you want to run or what method you want to run. So you just make it possible to select it dynamically on the fly. Some other interesting features, things like the ability to look up a subroutine by name, whether you have optional arguments, like you don't have to pass all of them, whether you can look up your arguments by name, things like grabbing all your arguments and bundling them into an array, which Perl 5 does by default. These are things that are considered really, really hard by traditional computer scientists. Really. And things like, passing in a hash and having it flatten out. Up until about 2 years ago, the JVM could not do this. It could not do this. And it still has a lot of trouble with it. Multiple dispatch, the ability to have multiple functions that you select at runtime. Polymorphic inline caching is a big popular one. And that is basically dynamically, once you dynamically pick which function you're going to execute, then cache it and store it. And then as you need to, add to it. Introspection. This is really the idea of being able to get in behind the scenes of your code, poke into the guts. So things like access information about where the source came from, be able to attach information, maybe annotations, to your code at runtime or during compilation time, and then access that information once you get to actually running it. Information about the runtime internals. A meta model is basically an object model that lets you peer into the guts of what your objects, what your classes are doing. Now this is all like completely. So this is a talk that I gave at the JVM Language Summit, and like people's jaws were dropping. And here I'm talking and I'm like, yeah, Perl does that. Yeah, Perl does that. Okay, yeah, Perl does that too. Some of the things that are interesting is thinking about how Perl 6 does it differently than Perl 5 as well. Some of these more theoretical features, Perl 6 provides a little bit better access to than Perl 5. I think some of that is the value of reflecting on how you implemented it the first time for several years. Dynamic compilation. So on the fly, adding subroutines or methods to your system. So eval, closures, continuations, and coroutines are functions that sort of capture some information about their surroundings, and then you can get back at it later. Just-in-time compilation. This is a very big optimization technique that is heavily used in static virtual machines. Is actually a dynamic technique. The ability to compile things on the fly at runtime down to a lower level of machine code. The idea of actually loading a library at runtime. Yeah, Perl does it. It's mix-ins, traits, and roles are dynamic features. They're like, so you can maybe have a class running and then layer in more information on top of it at runtime. Unloading is a feature that's not used very often, but it is actually used in one of the versions of the JVM. So you could have code that you load at runtime, and then maybe you're a very long-running program, possibly a daemon like an Apache daemon, something like that. Apache, a module running in Apache. So once you no longer need it, you unload it, and then you save the memory from it. So the basic idea on the static dynamic distinction is not so much to say that dynamic languages are better inherently by definition. both static and dynamic languages, we need C, and we also need Perl, and we also need Perl 6, which is, I think, a little even farther along the spectrum. C gives you tighter control, right? But a language like Perl gives you greater abstraction. And the greater abstraction means you can get your work done faster. The biggest cost these days in programming in general is not processor time. The processors get faster and faster. And even now that they aren't getting faster and faster as fast, we're splitting things out more and more into multiple cores. So the computers are able to do more work for us. The machines are fast. We're slow. You know, as programmers, we only have so much time in the day, and we're trying to get more and more done in limited time. So this is where dynamic languages take advantage of the situation. This is where dynamic languages really lead the way, and that's why the world in general is shifting towards dynamic languages. I mean, you know, we've been using Perl for decades. We think it's great, but a lot of the wider world is really just beginning to get a hold of the idea of the power of dynamism and what languages like Perl can do for them. Thank you.
You said you were talking on our conference. What amazes them most? What's the surprise for standard language size? They
So I think the biggest thing is coming to grips with the fact that a lot of the innovations that they have started to hold on so tightly to, things like the JIT and polymorphic inline caching, that these are actually dynamic features, and kind of wrapping their brains around the fact that computer science is moving towards dynamism. Because they've poo-pooed dynamic languages for a long time, you know, kind of put them to the side, not realizing that in the process they were actually turning into dynamic languages. The JVM is a dynamic virtual machine now, and they didn't plan that. They didn't try to go for that, but just optimizing for hardware, moving forward, the features that are making the difference for them are dynamic features.
One thing that we like to say, well, those guys, they're, you know, the static, we blindsided them. But we're also coming from a dynamic end of the spectrum, realizing that there's a lot of stuff we can do sort of semi-statically in a declarative way that will let us get the benefits that they get from their static languages, even while staying dynamic by default. So we're also learning things from them, and we're trying to increase our dynamic range.
A JIT is a great example of that, of sort of gaining the benefit. So with a JIT, you take your subroutine, right, at runtime, and you compile it down to machine code, so it can run very, very fast. So a JIT is a great example of that, where we're taking advantage of the speed gains, because the more work you can do at compile time, it is going to be faster at runtime because you're not doing as much work. So trying to kind of take advantage of those speed gains that they have had traditionally, but in a dynamic way, and still giving us all the flexibility that we expect.